From Chicago, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders of the 3D printing industry.
I'll touch three applications. Okay, end-use parts for end-use manufacturers that are looking for cost reduction out of an existing bill of material. That's the first application. I have a bomb. It's very expensive. I've designed it for CNC, for injection molding. Most of the parts there were designed for traditional manufacturing. And I have a manager who asked me to reduce 20% of the cost of this bill of material.
That's Omer Blaier. Omer is the CEO and co-founder of Castor. Castor is a software tool that automatically runs analysis to determine 3D printability for end-use parts design, chooses the suitable technology for print while maintaining functionality, and turns multiple parts into one to maximize manufacturing possibilities for unique designs. We discuss his entrepreneurial journey and what's ahead for the AM sector. Before we get started, head over to www.3Degrees Company and subscribe to the podcast. Remember, you can listen to the show anywhere you download your podcasts, including Spotify, Apple, Amazon, or Stitcher. Also, if you or your company are looking for materials, qualification, and general additive manufacturing support, reach out to the team through our website or via email at info@3degreescompany.com. All right, Omer, thank you so much for joining the show today. I'm excited for the conversation. I like to start with all the guests and kind of hear kind of their origin story, where they grew up, kind of what were some of their early days like that kind of planted some of the seeds to where you are today. So why don't we get started from there and see where the conversation takes us today?
Sure. First, thanks again for the time and the opportunity. So I'm Omer. I'm the CEO. It's like Homer Simpson without the age. I'm from Israel, 38, father for three. In my background, I'm a mechanical engineer, and I also hold an MBA in Entrepreneurship and Innovation. They both from Tel Aviv University, that's in Israel. I used to work for Stratasys for many years, and in the end of 17s, I started Castor together with Elad. Elad is my co-founder and CTO of the company. Elad and I know each other for 20 years and 5 days. We had a
very
union.
Specific.
Lately we served together in the Israeli Air Force. It's very common in Israel. We meet each other in the armies, and we started a company together. Elad is the VP R&D of the company. He wrote code for huge companies and developers. So he is my second half, I would say. As for me, when I was I'm a mechanical engineer who was a presentations engineer. Okay, I never really designed that stuff, but I was in an interesting position back in the days in Stratasys. I was an Objet employee. Objet was the jetting side of Stratasys before the merge, and through the merge and after the acquisition of Rabcad and MakerBot, I was in a position on the R&D side, but I was in a position to see customers, understand their needs, and really get to know to the technology, not only Stratasys, but all the technologies out there. Back then it was mostly around plastics. And we understood that the hardware is almost there. I mean, the hardware can do amazing stuff, the machines can do amazing stuff, but the software is missing, the applications to bring the parts to the printer. And with that mission, we started Castor. So yeah, that's how we came into today.
So when you were kind of growing up, were you one of those mechanical engineers and the stereotypical mechanical engineers taking apart your parents' clocks and other devices around the house, or was there other ways that you got inspired?
Yeah, I had a bike, like a motorcycle, and I had a tractor, which I drove, and I was pretty good with the hands. But again, I can't say that I'm a classic mechanical engineer who knows how things work just by looking at them and imagine why they chose this material in this dimension. I would say that what pushed me into manufacturing specifically, and additive manufacturing in general and additive manufacturing specifically, is the fact that you can create something new, create something that doesn't exist, and that's being more the innovation side of things rather than the engineering side of things. And once we've identified a gap in the industry, that's what pushed me for entrepreneurship. And yeah, it's been 5 years, so I can't really remember. but this is how we started this mission, right?
And what was your first introduction to 3D printing? Had you known a little bit about it, like before Objet, or like when did you start kind of seeing the technology more and thinking about it as part of your career path?
Yeah, we had a few, not a course, but let's say a class within a course within the university on additive manufacturing. It wasn't in a level that I can say that I understood what it is or what it means. The first time was I was a student. I started as a student in Objet, okay, on the testing area of R&D. Then I became an engineer, then a team leader, then a project manager, then a product manager. But as a student, I got exposed to the industry, and I would say that pretty fast I was able to visit customers, and then I was exposed to the other technologies out there. But yeah, I think the main application back in the days that it was before the hype of the merged Objet and Stratasys. There was a lot of hype around hearing aids and liners of dental, which is still a very good application, end-use application on the plastic side, on the polymer side. So these were the first pictures that I saw of end-use parts being manufactured in hearing aid or dental liner, which is pretty disgusting to look at. But once you understand it's printed, then you think it's cool. So yeah, these were my first observations, I think.
Yeah, my first real additive manufacturing, like true end-to-end manufacturing experience came alongside the Objet. I was working at Burton at the time, and we had a holiday party coming up, and I think the guys had designed some VIP and VVIP rings, and we got like 300, maybe 250 on one of the big Connex systems. And so I was one of the new guys, and we spent the whole night scraping out the the support and getting them all clean, and fingers crossed that it's not going to turn anyone's hand purple from missing any of the support. So it's certainly a great technology. And as maybe kind of a perspective, like how big was Objet before the Stratasys merge? Like what was it a sizable company? And like when did you start? Like how big was it when you started?
Yeah, when I started, let's say it was a few hundreds employees, let's say 400, 500, and R&D with about 100 employees. It was in the early stages of mixing materials and mixing colors. So not only a single material based on print. And then it started to be interesting. And it was a family feeling. I mean, it was a very, very, I would say cozy, because there were 3 floors in a building, but there was a feeling of innovation going on, and a lot of communication among the engineers, where you could learn very fast and move very fast. and yeah, as you said, when the colors came in, were it's something that catches your eye, right? I mean, it's something that must understand how it works, or how come this can be in full color, or it can be in two different colors, etc. This is where I joined, and it caught me in the same way as you described. Yeah.
And as you think about kind of where you, and we'll get to kind of the Castor piece in a little bit, but I'm curious as you went through kind of this early part of your additive career at a company that was kind of small, medium size, innovative, got acquired, that transition, and likely changes of personality, leadership, how the company runs. Like, what were some of the lessons that you kind of took away for that you maybe like put in your back pocket as wanted to start a company one day? It's like, oh, I'll never do that. It was like that. I'll never make that decision. Or like, how do you think about even keeping kind of a culture that you want to promote or you want to work within?
That's a good one. I can say that for me, I mean, I was an engineer. I wasn't part of the discussion around the merge. I wasn't part of the business discussion about the high level business collaboration between the two companies. I was an Objet employee, and I kept being Objet employee after the merge. But what really caught me was the culture mix that the company entered into. We were, let's say, R&D was 85% Israelis. Business units were channels all around the world, but the headquarters was led by Israelis. And when we started to host Americans that came to the office or to meet with them online, etc., those very basics of in Israel, when an elevator hits the first floor, the door opens, and it's like a diffusion. It's like a diffusion. Everybody goes in and everybody goes out in the same time. You don't know how it happened, but in the end of those 5 seconds, all the people that should be out are out, and all the people that should be in are in. Okay, which is totally different than the way it works in the USA. In the USA, the door opens, everybody who should go out are going out, and those who should go in are going in. Okay, it's a culture difference. It might seem like small mimics, but it requires a lot of patience, I would say, to grasp that. So the first lesson that I've learned: Israel is so small. Anyway, we must go through the American market to succeed as a company in manufacturing, and the willingness to accept to succeed, to do this successfully, to mix cultures successfully is crucial for the organization. That's what I learned.
Yeah.
Sorry for being psychological.
No, that's I get what you're saying. And so how long did you spend at Objet, and kind of what was that transition to more the entrepreneurial route? Can you talk about kind of how Castor got started? What was that path like?
Yeah, so I started in Objet 2012, I think, and then the merge was 14-15. It wasn't a specific event; it was like a year of production. Then there was a big hype around the combined Stratasys, hype about prototyping in general. That was very that affected all the others. And immediately, we saw 100 desktop printers companies coming up in 1 year. And once this whole hype went down, let's call it this way. It was, I don't think it's exploded, but it went down. It came down a little bit, and the industry started to think about end-user manufacturing, and prototyping was over. This is exactly the point in time when I started my MBA in Colorado University, and then I also started looking at end-use manufacturing and met customers at work, and I also met international students, and a lot of ideas came to mind, and we started as a small project in the MBA. And once we saw that people are listening to what we have to say, I decided to leave the company, and we started from something else, and then after a very short period of time, mainly due to the very intense or very crowded VC scene in Israel. When we started to pitch investors with the idea, it helped us to tweak it up to the point of what Castor is doing today. That we started a bit differently, and we started from, and I knew a lot. For 20 years. I pitched him. It took me like half a year to pitch him over a coffee, then over lunch, then over dinner, then I pitched his wife 5 times, and then the first investor is her wife. Then I convinced him to leave his job as well, and we started Castor.
Okay, so he was working full time, not at the MBA. So okay, right. Did you have other partners at the while you were doing your MBA program working on this idea, or was it mainly just you?
We had, I wouldn't call it partners, but we did the atmosphere. The atmosphere was that okay, who is aside? I mean, who is going with us? The first legal help, the first accounting help, the first advice on business development came from this environment, and that was very encouraging, very inspiring, very pushing us to do entrepreneurship. And I think it pushed us pretty far. So the first few partners that we had were from that environment.
And it's interesting. Can you talk a little bit about the, I guess, entrepreneurship scene in Israel? I mean, it's anywhere you go, like entrepreneurship is probably like, if you have an MBA class, maybe it's like maybe 10% or maybe 15% go to like an entrepreneurship versus banks and consulting firms and whatever it may be. But what was the culture supportive of entrepreneurs and going that path? And
that's a long discussion. I think Israel at first it's the driver of the economy in Israel. The high-tech scene in Israel is one of the strongest things that Israel has to offer, other than defense and security. And I've done an MBA specifically in managing technology, innovation, and entrepreneurship. There were few CEOs came out from that class, and in general, the Tel Aviv University is ranked, I think, like number 8 in numbers of entrepreneurs, and number 3 number of unicorns coming from specific. Don't catch me in the numbers, but it's like Silicon Valley, or it's like MIT, and Israel is 9 million people country, whereas it's only the size of Manhattan, right? Yeah. So in that perspective, there is in Tel Aviv specifically, there is like almost a lot of people are choosing that path, because the the knowledge of the experience who've done that 10 years ago are sharing, because the government subsidized projects that are being very innovative, because the universities are pushing for entrepreneurship in the professional. There are those who already done 3-4 times an exit. It's very much pushing you towards that direction. It does requires a lot of courage to compromise in other stuff in life, but I can definitely say that it's not weird to think on going on your own high-tech startup in Israel. It's pretty being pushed to that if you have the capabilities and the environment to support you in that perspective.
Okay. And so we haven't really talked about it much yet, but what is Castor? What's kind of the technology? What does it do? What's kind of the pitch?
Right. So Castor is a software company. We're doing what's called automatic BOM optimization, bill of material optimization. It's first a decision support system for utilizing industrial 3D printing, which means we're enabling manufacturers like Stanley Black & Decker and ThyssenKrupp and John Deere and others. We help them to decide whether to prefer additive manufacturing over traditional manufacturing methods when it can save them time and money. We're doing that by analyzing CAD files and 2D drawings, technically and economically. But what's different about Castor is that we're doing that in scale, which means Castor is usually being used as a screening tool where you can upload the whole dashboard of a car, the whole inventory list of spare parts, the whole assembly or sub-assembly of something that a manufacturer wants to optimize or to check whether additive can help. And within seconds, we give a quick assessment whether there are parts that make sense to use additive manufacturing out of those a lot of parts at once, and highlight the benefits of them, whether it's a supply chain benefit, sustainability benefits, a cost reduction benefit, lead time acceleration benefits, etc. It's hard to identify those cases. It's not common cases that a part is not suitable for additive manufacturing. But once there is a part that makes sense, either as is or either with design changes, and I'll touch that in a second, then we're providing all the information around this finding, and the user can interact with the software, can change the assumption and check even like a little deeper analysis, a little deeper analysis on the business side as well, to get the basics of understanding whether there is really an option to use additive instead of traditional manufacturing for a specific part. When I've said design changes, one of the biggest benefits that the software provides is the ability to automatically identify DFAM opportunities from a whole bill of materials. So, for example, we're very good in parts consolidation, the ability to combine multiple parts into one. So to identify adjacent parts, 3, 4, 5 adjacent parts out of a large assembly, and say, hey, those 3 parts as a single part can save money. And
how would you go about, like, is that like, okay, there's the baseline assumption, okay, these parts are next to each other, so like that's a requirement for consolidating. Mm-hmm. But is it then like material, like, okay, they're all the same material, which is good, they all see the same sort of environment, like, is it, there's probably a lot of assumptions, right, on that.
It's a 60-page patent, so I can't. I'll try to summarize it into a few sentences, but everything that you said is right. I mean, first you need to identify the 2 parts are adjacent. Right? There are a few rules that the part should stand in. We are identifying the connection method between 2 adjacent parts to say that there is no movement, that they belong to the same environment, to the same space, or have a relationship between them. Okay, and then once 2, 3, 4, 5 adjacent parts were identified, we're applying all the rules of a single part to think whether as a single part they make sense to use that manufacturing. Key values of 7 material properties, geometry limitations, 12 different tests there, small holes, small thin walls, accuracy of tolerances, etc. Cost analysis, whether this whole thing has a chance to be cheaper than 5 different parts being made in CNC or injection molding or die casting or vacuum forming, etc. Because otherwise we don't believe that it will be very hard to convince engineers to use additive if we don't show them the financial benefit. Lead time analysis, whether this single part using a single package, a single thing can arrive faster than 5 different parts being arrived separately to manufacturing facility somewhere. And eventually we're doing stress analysis. We're also doing assuming forces, or we're asking the user to put forces, and the user can, as a single part, the user can assess whether the part, what's the likelihood of failure of the part in the real life, according to finite elements analysis. For anisotropic materials, based on a specific tray orientation that we choose for the consolidated part. So if the answer for all of that is a green V, then we're highlighting this opportunity out of a lot of parts at once, automatically for thousands of parts at once as a screen.
Yeah, and then comparatively, like the status quo process right now is you've got 1 or 2 engineers who gets some homework from the boss saying, hey, like go through our product lines and tell me which ones are viable for 3D printing. And if you have 10,000, like it's going to be a nightmare to do that. And so your software kind of takes that process in a very structured, quantitative manner and kind of does that sifting and does that analysis in an automated fashion.
So I think there is a layer of providing an automatic tool to those who have this role, as you said, to analyze a lot of parts at once and identify. And there is a layer of intelligence, like the parts consolidation, like the weight reduction identification that we're very good at. Okay, we're not a topology optimization or a generative design company, but we are very good in identifying bulky parts that if you'll make them hollowed, they will utilize the benefits of additive manufacturing. That's an intelligent layer that even a student or an experienced additive manufacturing expert that go over 10,000 parts in I don't know, in 2 weeks, it will be hard for him to think on those options. We're highlighting those again automatically out of a lot of parts at once. I think we've talked to one of the largest car manufacturers that we all know in Brazil. Like 2 months ago, they hired an expert to analyze parts. He analyzed 2,000 parts over the last 6 months. We're analyzing 2,000 parts in 5 minutes. That's pretty much the equivalent. Okay. So we're not replacing the engineer. We're giving them a tool to do what they need to do automatically and leave them to focus on those 50 parts that make sense to do a deep dive analysis. On those 100 out of 10,000, it makes sense to dig into the numbers. You see what I mean?
Yeah, absolutely. Because there's still a level of like, even if it's a green V, like there's more steps afterwards to get it into into manufacturing and convince someone that this is a good switch.
No question. We're either integrating into the solution coming after Castor from a software perspective, deep dive analysis tools, workflow solution tools. If you want to send 5 samples in a service bureau, through a service bureau, security solutions, all those kind of stuff that are after Castor. Castor is 2 steps before that. Okay, so we're either integrating, shifting the user through those solutions coming after Castor, or but what we state clearly, you need an engineer. It can't happen without an engineer.
And
those steps are first.
And can you describe kind of with your typical customer, like how does or organizations that you're working with, like how do these conversations go? Like clearly there's there's an end user that's like running the software and kind of manipulating and putting the files in. But are there usually, like in successful cases, or like as you're seeing more and more people think about additive, is it a entire organization decision, or like a pockets of organizations say, hey, like this is a real problem? Like when does it become elevated enough that it makes more sense to go with a automated, intelligent software approach than just throwing a guy at the problem and say, like, come up and see what it means? Like, where's the value shift have to come in, or when are people starting to see it make a lot of sense?
So I'll try to generalize the answer that I mean, the answer to your question is the holy grail. If everybody had an answer, then they would convince everybody to use additive. I'll touch three applications. Okay, end-use parts for end-use manufacturers that are looking for cost reduction out of an existing bill of material. That's the first application. I have a bomb. It's very expensive. I've designed it for CNC, for injection molding. Most of the parts there were designed for traditional manufacturing, and I have a manager who asked me to reduce 20% of the cost of this bill of material. Okay, that's one application that we see a lot. The other is spare parts, jigsaws and fixtures, production line aiding tools, etc. That's improving the production line, the operation, the overall thinking of an operation manager, maybe a purchasing manager, a procurement manager of the company. That's application number two. And the third is R&D, improving. It's now more NPI rather than prototyping. Prototyping was mostly in 2016, 17. Okay, now it's NPI. It's those first 500 units, NPI, new product in production. The first 1,000 units that I'm doing in an alpha beta mode, and I need to, and I'm considering using additive to ship that to my customers. So these are the three applications. Okay. In the first one, the value is cost reduction, right? I have a part. It's a low volume, high mix product that I'm working on. Low volume means thousands of units in a year. High mix means high customization, high variety of components, high complexity of the geometry, and I have a task to reduce costs from an existing design. I can give an example of Stanley Black & Decker in Danbury, Connecticut, using us to reduce a cost of a machine that makes helicoils. Helicoils that being used for automotive, aerospace, medical devices, etc. Okay, but the task was to reduce cost from the machines. Okay, I'm talking on a machine which is in the size of this room. It has hundreds or thousands of parts in it, and they uploaded assemblies and sub-assemblies to identify parts that make sense to use additive. So in that application, we've identified a part that is a metal part that was delivered in 9 days versus 9 weeks and saved 50% of its traditional manufacturing costs. They printed 5 samples, they tested it for 2 months, and it's now being used as an end-use part, which is a part they never thought of. Okay, they're not experts in additive there, and they found an opportunity that wasn't on the table before using an automatic software to identify that. Okay. So that's the value is cost reduction, and that's for non-experts to identify opportunities. Let's take jigsaws and fixtures and spare parts. Okay. I won't use names, but one of the largest food and beverage companies, they have 2 million spare parts sitting in a warehouse that needs to serve 400 breweries around the world. And these 2 million spare parts are a huge supply chain issue for them. Okay, it's not that easy to send a spare part today from one place to another in the world, and they're looking for a way to identify parts that can be that they can avoid keeping on a shelf. Okay, what we all call digital file inventory, right? It's a buzzword that we use for a few years. So they're really looking for a digital file to replace 1,000 units sitting on a shelf for 10 years and are being kept just in case, the long tail spare parts. So they're using Castor just to know, they're not printing. Okay, they're using Castor just to know whether there are opportunities like that out of 2 million spare parts. Okay, it's also a sustainability thing for them. They want to show that there are opportunities to reduce carbon emission, and if I can avoid manufacturing 1,000 units and keeping them on the shelf, and then make sure that the obsolescence for sure will consume CO2, then I can make only 3 parts. They can be manufactured in a service bureau 3 kilometers from where they actually need them, and they're using us to show this carbon emission opportunities to their managers. That's a clear added value there. So that's spare parts, that's either supply chain or either sustainability. And the last example is R&D. I can say that we have a company called Maxion Wheels, for example. They're a tier 1 manufacturer of cars infrastructure, rims, trucks, really the infrastructure of car. And they had performance issue that they were looking for a way of improving that using additives. Pretty rare. Okay, we all know that you probably need either DFAM or some kind of an improvement in mechanical properties to do that, right? But in an environment where there is a high replacement rate of a component within a working station at such a company that is doing tons of rims in a year, then for them, identify the opportunity to use additive created a whole different scenario of R&D cycles around the specific task that they need to do to create a rim. So they used us to, again, identify the opportunity that a metal part can replace, according to the dry numbers, can replace a metal part. And yeah, it went pretty well. Margin steel instead of tool steel, very strong, okay, high ultimate tensile strength steel that was replaced by something that is less, that the ultimate tensile strength is less than the original traditional manufacturing material, but still doing the job. It's very available, and the availability is high, so you can get it pretty fast and you can replace something. So anyway, it was a good case of opening the minds of engineers in R&D phase to think on additive and identify those cases. So this is the value here is education to the organization, education to somebody who is an additive manufacturing expert identified a case using a software, and he told about it to the whole organization. And the value was education around using additive manufacturing to the other engineers. Okay, so cost reduction, supply chain benefits, sustainability, and education. These were the.
And I imagine as well as the technology, the manufacturing, the printing technology, the materials improve, get cheaper, your software only becomes more valuable, right? Because there are more and more opportunities to potentially use it. Yeah.
We have more than 150 industrial grade printers in the database, more than 250 different materials today in the database. We're updating that all the time. We tend not to do prototyping and pure desktop solutions, so it's not like it's being changed every day. A new material is being added every few weeks, and a new printer is being added, let's say, every month or so. and we're helping them to keep up with the rhythm of development. That's a huge advantage that we have. This huge.
And maybe taking a step back out of the technical stuff, like what's been the funnest part of running your own company, or having kind of going off the entrepreneurship path?
The fun. Ooh, I forget. I used to have hobbies, but I don't.
Well, you've got 3 kids too, so
I have 3 kids.
it's not just the company.
Being a CEO and a father, that's for 3 kids, 10 kids. That's not fun. But what I can say first, in a startup, there is the whole thing around fundraising. Okay, I can't say that it's fun, but it takes a huge amount of energy, time, and expertise, I would say, around that. What's nice around raising meeting investor in general is, first, they are smart people. Okay, they see a lot of things that will happen in the future, and they can connect the dots. They can say, okay, even if you're just pitching them a story, they have the ability to see how it may look like, although the reality today doesn't support that. Okay, so it is an interesting part of a startup to pitch a story that doesn't exist, and then after 2 years to really create parts consolidation that, as I've said, that's a patent, and that's something that took us 2 years to develop. Okay, that was an idea to identify adjacent parts that make sense to be combined together. It's hard for an investor to imagine that. Okay, that it's happening with an automatic tool, and that's one side of things. The other is, we've talked about culture. We've talked about the cultural differences between Israel and the rest of the world. Israel is very, the rudeness, the intensity, everybody were in the army thing. That's very much affecting the culture of the companies, but then you have an opportunity to create your own culture. I mean, to bring your own values to the culture of the company, and to see, for example, moving fast. Okay, to see how a startup like ours can move fast in relations to what's the large CAD companies are doing, or the large PLM companies are doing, or the large ERP companies are doing, or the large TDM companies are doing. That's inspiring. I mean, that gives you power to say, hey, if I'll do that faster, I can be first. And if I can be first, I can be better. And if I can be better, I can raise money. And that's something that I think it makes a startup more special.
Awesome. I just got 2 questions left. First, kind of before we started chatting, you had mentioned that you've got some further developments. You kind of touched on it with one of the example case studies, but the kind of looking at CO2 and kind of carbon emissions when it comes to manufacturing. So you want to tell us a little bit more about how that's developing in the coming months?
Yeah, thanks for asking. I didn't mention. I think I've tried to emphasize how does it relates to the customer. There are companies that are being measured on innovation, on showing innovation around identifying opportunities to reduce carbon footprint. And we all know that additive has a chance to play a role in this game, but it's hard to get those because we need to identify them. So what we've developed is a calculator, an automatic calculator to assess carbon emission reduction that additive can provide versus traditional manufacturing. and it's part of our screening tool. I mean, you can now use Castor and leave the cost reduction, lead time assessment, all of that aside, but use Castor as a tool to assess whether there are parts that make sense at the manufacturing from a sustainability perspective only, and to screen a lot of parts at once and identify those. It's a calculator that takes into consideration the whole life cycle, what's called, okay, the full life cycle of a part. The material it's being made of, what energy was used to create this material, the energy being used to create the parts, okay, CNC or injection molding, die casting versus additive. Then the product use itself, if it's an aerospace part and you manage to reduce 1 kilo and that's flying on an aerospace for 20 years, that's reducing a lot of CO2. But to reduce 1 kilo from a robot sitting on a floor, that's saving less, right? So the product use, the transportation of around the part in the supply chain arena of the part in traditional manufacturing versus additive, and the end of life. What do you do with a part after, in an industrial application? What do you do with it after it's finished its role in its life? The disposal ways, shelf time, etc. We're taking all of that into consideration, and we're trying to highlight opportunities where additive can help. We have few partners that we're working with within the industry on that. So it's not like only Castor came up with that. Some of the largest brand in our industry. And we are gonna issue end of the year report for 2022 that includes our review, what we saw when we've analyzed parts based on carbon emission reduction, and there are some interesting findings there, like analyzing 50,000 parts and see what makes more sense to that from a sustainability perspective. That's you can visit our website, 3dcastor.com, find this report, but we don't do sales today. Yeah.
Perfect. So one last question.
Yeah.
I've been asking the last few guests kind of this as we wrap up, but what's a favorite book or a meaningful book that has kind of impacted how you think in your career, or something you've recently read that you'd like to share with the audience?
That's an interesting one. I don't know how much, not a book, but how much of you saw the recent episode of it's called The Dropout. That's a Disney Plus. That's on Elizabeth Holmes and everything that happened in Theranos. I think that's an enlightening way to see how a startup reacts to the environments and what things can happen. That's recently, I just saw the show. I thought it was good. And I read a book called The Hard Things About the Hard Things. That's on Ben Horowitz. He was a very successful entrepreneur back in the days, and he wrote about it's hard about having a startup, and I think that one of the, until you're facing that yourself, the book describes in a very good way what you are about to face, and that's a good preparation for those who wants to start a startup. Yeah.
Excellent. Well, thank you so much for joining the episode today. I really appreciate you sharing your story and all the hard work that you guys are doing there, and look forward to seeing you in the new year.
No, thanks again for the time and the opportunity. And we're now before Christmas, so Merry Christmas. And I know this will be in the air after, so Happy New Year to everybody. And thanks again for the time and the opportunity.